Boom. All right. So first off, we've been talking about derivatives. There's a little bit of notation for derive this. Okay, like so all these four things mean the same thing. So f prime of x means the derivative of f dy dx. That's how you say that, or dy over dx, but most people just say dy dx. That means the derivative of y with respect to x. So like dg dt would be the derivative of g with respect to t. It means derive g. Okay, and t is the independent variable, like the x variable, if you think of it. D over dx, this little symbol here, means derive what is ever sitting in the brackets. So if I said d over dx of x squared, every single person would tell me, oh, 2x. Okay, so d over dx it's called an operator. It just means derive this thing. And that's exactly what dy over dx is doing over here. Like that's really just d over dx of y. But they put the y up top like it's multiplication, even though it's really not. Okay, and then y prime is just another way of saying the derivative of it. Cool. So things we already know. The power rule, we've seen that before. Okay, look at my funny comic I put in there. So the power rule just says if you have x to a power, or there could be a coefficient out front, but I didn't put one there. If you were to derive it, and that means if we did the long way, that whole f of x plus h, or if we did the 2 points and found the slope between them and found the limit between those 2 points, you're always going to get this. Okay, so that means if f of x is 2x to the fifth, f prime of x is 10x to the fourth. You multiply the exponent down to the front, subtract 1 off. And we've seen that. That works with fraction exponents. It works with negative exponents, but it has to be a number times x to a power. Okay. I wrote 10x to the fourth. Okay, so let's just do another example just to make sure everyone's clear. I'll do 2 examples. If we had g of x equals 4 square root of x, all right, then g prime of x, you got to think of this right here. This isn't the derivative. I'm rewriting it. It's 4x to the 1/2. That's what that really is. Okay, so when you derive that, you would do 1/2 times 4. That's 2x to the negative 1/2, which is the same as 2 over root x. Okay. And again, I really think you should just memorize that if y is root x, then the derivative of it is 1 over 2 root x. We see square roots enough that you just memorize that little rule there. Like, I don't know, I just find this intermediate step right here where kids write the exponent sometimes just adds a little bit of trouble because they end up messing something up in there somehow, which seems weird because you're writing more. But either way, we got that going on. And then I'm going to do one more example of the power rule over here to make sure we're all okay. If h of x was like 6 over the cubed root of x, cool, squared for some reason, whatever, just making this up. You need to rewrite that as 6 times x to the negative 2/3, and that's what you derive. That's what the power rule was using. So it would be negative 2/3 times 6, which would be negative 12/3, which is negative 4. And then you would get x to the negative 5/3, which just puts x down here, and you leave it like that. So hopefully everyone's on board for the power rule. That's if you derive a number times x to a power, that's what you get. Okay? All right. We also have the derivatives of the trig rules. And if I had more time, I'd go into why these are what they are. I'll show you some of these later on, why they are what they are. Okay? But these are in your notes. You're going to memorize these, right? And I know you're at home and you can have this next to you all the time. Okay? But you need to memorize these. Like I'm going to start giving you timed quizzes on some of this stuff. And you need to have this memorized. So that would be a good thing to do by Monday. Make some flashcards. Okay? I can't do it for you. If we were in class, I tell you on Monday we're having a little quiz. Okay? And you'd have to have these memorized. You wouldn't be able to look at them. So you need them memorized. If we get further in this class and you don't have the rules memorized that I'm telling you to memorize, you're going to have to look up everything, and it's going to be a huge pain in the ass, a pain in the butt. So you don't want to deal with that. Memorize these things. Okay? But just so you see it, there's a couple patterns. The derivative of sine is cosine. So cosine tells you the slope of sine, is what that says. But the derivative of cosine is negative sine. And if you're paying attention, check this out. The derivative of any co-trig function, cosine, cosecant, cotangent, the derivative of all of those is negative something. See those patterns? Okay. The derivative of the other three are all positive something. Cool. you're also going to see, again, patterns. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So there's some symmetry, not really symmetry, but some similarities between them. The derivative of secant is secant x tangent x. And if you pronounce that phonetically, that says sextanx, which is, I think, a little funny. Okay, so you got that going on. And then the derivative of cosecant is negative cosecant cotangent. So if I were you, I mean, you could have printed these notes out, but I think writing them down helps you memorize that. But that's those. But so them by themselves aren't very interesting, right? That's just a rule. Derive this. They'll always be the same thing. But we're going to start looking at what happens when we have combinations of functions eventually. So the first few rules are how do you derive specific types of functions, right? We have power rule. We got the trig rules. Down here, I'm giving you the exponential rule. Also something you need to memorize. Okay, when you take the AP test, like I imagine we'll be back in school by then. If you don't have these memorized, again, just a huge pain in the butt. So I know I'm giving you a lot currently. I think most teachers would go a little bit slower on this, but I'm giving you all the stuff you need right up front. So you see exactly what it is, and then we're going to practice with it. Okay, so if you have an exponential function, which just means it's a number raised to a power, a variable power. Okay, what you get is the natural log of the base times the number to the power again. So you get the same exact thing, which is kind of nice. All right. So when you derive 4 to the x, you get natural log of 4, ln of 4, times 4 to the x. So go ahead and derive 1 and 2 for me real quick. So it's a to the x, e to the x. I'm going to go right back to it. But I need to see something. Yeah. Did Ju Young show up? No, but Tyson did. Hey, Tyson, man, you've been late a bunch of days in a row, dude. I don't know what's going on, but you got to get here on time, man, okay? That's all I'm saying. All right. So hoping you're done. This should not be crazy difficult, right? G prime of x is just the natural log of 8 times 8 to the x. Cool. The derivative of e to the x, so h prime of x, would be the natural log of e times e to the x. But the natural log of e is just 1. So h prime of x is really just e to the x. Isn't that nice? Okay, so e to the x is the only function, except for 0, we don't count that. So the only function that derives to itself, okay? Which means, let's think about this, okay? Think about what e to the x looks like. Goes up like that, right? The y value of e to the x, like when you put a 2 into there, you get this y value up here. The y value is e squared. But e squared is also the slope of that curve, which is crazy. The y value and the slope are the same thing. So if you think about it, as the y value gets bigger, the slope has to get bigger as well because they're the same. So it gets steeper and steeper and steeper. And that's exactly what an exponential function does. Okay? And as the y value gets lower, closer to 0, look, the slope gets really close to 0. It flattens out. Okay?
Mr. Smith?
Yeah.
So say you have a function that has e of x, e to the x, and then has like some other things involved. How would you know if you're looking at its first derivative or second derivative, or if it's just itself, if it's always going to be the same?
Well, we're going to get into some combinations of things in a minute here, okay?
All right.
So it'll also be how is it labeled? Okay, so you'll see. I don't think it's going to be as complicated as you're thinking. Okay, like I think things are usually labeled pretty clearly for us.
Okay.
Okay, so but let's just review what we've gone through so far. We can derive a number times x to a power, even if it's in a root, even if it's in the denominator. We know the derivatives of the trig functions, which you're going to memorize. We can derive exponential functions. Okay, other kinds of functions you've seen are logarithms. You've seen logs before. the derivative of a logarithm, so log base a of x, which is different than a to the x power, right? That's exponential, is 1 over ln of the base times x. So when you derive log base 3 of x, you get 1 over ln 3 times x. And notice the x is down in that denominator. So I find like a lot of students get in trouble because they get a little sloppy and they start writing like, so check this out, they might write 1 over ln 3 and then x. And then you're like, well, is that in that denominator or not? Okay, so when you're making fractions, just be neat about it. Like make the fraction bar big and put the x down the bottom so you're very clear about it. Okay, if something goes on top, then put that number on top. Cool, but go ahead and derive these two right here. Log base 2 of x and ln of x, which you will remember. No one writes it like this. This is like little training wheels, but ln of x is log base e of x. Derive those.
I'm hungry now.
Talk about me, dude. You did that, right? With grandma? What do you think you don't know? Okay. So I'm hoping the calculus spectacular skills you have over there are telling you this is the derivative of that, 1 over ln 2 times x, and h prime of x is 1 over, it would be ln of e, but that's just 1, x. So yes, technically there's an ln of e here, but that's just a 1, so you don't even need it, okay? Okay, and if I'm telling you ln of e is 1, and you're like, what the crap does that mean? I forget all that stuff. You need to go back and review your logarithms, okay? Normally I would do that with you in class, but we don't have time for that. Hop on Delta Math, hop on Khan Academy. You need to be able to evaluate logarithms, okay? Nothing crazy, you just know what they mean. Like, for instance, this. You should understand that log base 2 of 8 is 3. So if you don't understand that, let me know, okay? You should understand log of 1 over 100 is negative 2, because 10 to the negative second is 1 over 100. You should know that ln, I'm just evaluating logs here, of square root of e is a half, because that's e to the 1/2 power. Okay, and the last thing you should know is, there's some other stuff, but you should know ln, negative ln of 3 is the same exact thing as ln of 1/3, because there's a log rule that says, so this is really negative 1 sitting out front here, right? You're allowed to make that the exponent of the argument of what's inside those parentheses. So negative out front of an ln is the same thing as ln with the inside flipped. And I'm only bringing that up because on the AP test, sometimes kids get this answer and they're like, oh, right. And then they can't find their answer because the AP test has this written somewhere. Okay? All right. So we got those. Let's keep going. Check this out. I don't know if you guys got to arc trig last year. Talk to me, somebody out there. Did we get to arc trig?
Nope. We did, but we didn't. I guess the way it was taught to us was think of it the same as inverse cosine or inverse.
Okay, good. Okay, good. That's good to hear too. So arc sine is the same thing as sine inverse. Okay, so this is not about the derivatives. This is just about this function. Arc sine is sometimes written as sine inverse, like that. Here's what I want you to know. Sine with a little negative 1 does not mean ever. It does not mean 1 over sine x, okay? It's just bad notation. I know to the negative 1 usually flips it over, okay? But that's not what that negative means there, okay? It means the inverse of sine, which is different than 1 over sine. 1 over sine is cosecant, right? These are not equivalent. They are not the same thing. Arc sine or sine inverse is the inverse of sine. So they flip the x and y values is all. So if sine of pi over 6, everybody knows instantly, is a half, then arc sine of a half, all that's asking you is where does sine equal a half for the first time? pi over 6. That's it. That's what arcsine does. You put in the value and it spits out the angle. Okay? That's the same for all these arc functions, okay? But we need to know, there should be a parenthesis here, right? But we need to know the derivatives. We need to know how do we tell the slopes of these things. And there they are. And you'll notice some similarities between these. The derivative of arcsine is 1 over the square root of 1 minus x squared, while the derivative of arc cosine is negative 1 over the square root of 1 minus x squared. Same thing, just negative. Cool. Arctan and arccotan, same thing. They're the same exact thing, just one's positive, one's negative. And arcsecant and arccosecant, same thing. Okay. Again, if I had more time, I'd explain arc-trig to you very, very, very well. But it just doesn't matter as long as you understand these key concepts. Okay. We'll look at the graphs of them later. Okay. But you should understand. Like if I ask you, what's arc sine of 1? I'm asking you, where does sine equal 1 for the first time? Just the first time. And that is pi over 2. Okay? But for us right now, our main goal is to learn how to find their derivatives. So that's what they are. Now, this might seem like a lot. It is a lot. I'm not going to lie to you. There's a lot going on here. However, let's just take a look at what we've done. We've gone through all the functions you need to know, really, okay? So we've got power rule, which is numbers to powers, right? You've seen those since algebra 1. Now we can find all their slopes. Okay? We get E, seriously? Hey, chill, man. All right, we've got the trig functions. We've got the f-trig functions in addition to that, and then we have logs and exponents. That's all the functions that you guys have learned about, really, right? You haven't learned any other crazy functions out there. So those are all just the basic functions you've been working with algebra and pre-calc. After that, we need to go through the combinations of these functions. And there's 4 ways we're going to combine functions. Okay? The first is by adding and subtracting them. And we've already been doing this. Okay? If there's a plus or minus between functions, you just derive each one separately. Okay? And again, we've seen that with the power rule. So when you derive this function right here, you just, because there's a big plus right in the middle, you just derive each one separately. No problem. Okay? The same thing would happen. E, plug his headphones in, dude. Okay. If I gave you something like this, cosine of x plus ln of x minus arctangent of x. Go ahead and derive that, because they're all separated by pluses. What would h prime be? I know you got to look back in your notes. These are all just formulas. This is the recall center of our brain. The derivative of cosine is negative sine, plus the derivative of ln is 1 over x, minus the derivative of arctan is 1 over 1 plus x squared. Anybody got questions on that? Feeling good? Okay. There's only, we're still connected, right? You guys are all here. Hello. Okay. Okay. Yes. So we also have, let me think here. When I'm asking you to derive something, okay, as we go through this and learn how to do this, key things. Number 1, I'm asking you for the function that will tell me the slope of the original function. That's what I'm asking you to do, okay? Number 2, you need to take stock of what functions are present that you need to derive. That's what we just went through. Are there logs? Is there trig or arc-trig? Are there power functions, okay? Can I simplify it to derive it, like we saw with, let me see here. We saw with things like these. I want to make up a simpler one, but we did a whole lot more complicated ones of these. Like if we had that, right? Well, we can simplify that, and that's what we did. So before we derive it, simplifying it makes sense. This is x to the negative 1 plus 3x to the negative 2. And we would derive that. Way, way simpler. Now, you can't always simplify something, but if you can simplify it first, you should. Okay? Then you need to think about, ready? So we're looking for, are they being multiplied? Because if functions are being multiplied, sadly, you cannot just derive each of them like we could with the pluses. Remember, with the pluses, we could just derive each piece separately. And I zoomed out there for some reason. So, like here, 3x squared just derives to 6x. This derives to that. And you're basically done. The plus stays in the middle. If you are multiplying functions, there's a little pattern to it. And again, I can prove this to you. This is not made up or handed down from the math gods. This actually works. It's a thing. Okay? However, when you derive multiplication, there's a pattern to it. It's called the product rule. And it's not crazy difficult. Check it out. Okay? But you do need to memorize this rule. It says, derive the first function, leave the second. Plus, leave the first function, derive the second. Okay? So, in my example, I'm giving you x squared times sine of x. That's two functions being multiplied. To derive them, to derive that f of x, you derive x squared first. That's the 2x. Leave the sine x. Plus, leave the x squared, derive the sine x. Okay? Try these down here.
And then it will get more people on the screen.
What's wrong?
I only can see 6 of them.
Okay. Sure. So here,
I already know.
you change layout. What do you have in the front? Oh, yeah, right here is what she's saying.
And I didn't. I don't want to.
How many kids in the class? What do you think of that?
Just put it all the way up.
No, this is good.
I don't know.
Boy.
There's 19.
Okay. So we have g prime of x. I'm really hoping you guys are trying these over there and not laying in bed. You got to treat this like a real class here. We're going to get through this. So, g prime of x. You derive the first thing, which is root x. And I told you, just go ahead and memorize. Root x derives to 1 over 2 root x. Multiply it by the second thing, sine x. Plus, leave the first thing, root x. Derive the second thing. Sine derives to cosine. We're just using all the individual rules we have and putting them in their places. Questions on that? Feeling good? Number 2, h prime of x. There's two things being multiplied here, okay? This is one function, cosine is the other. When you derive that, you get 12x cubed. That's the derivative of the first. Leave the second, cosine x. Plus, leave 3x to the fourth, derive cosine. But the derivative of cosine is negative sine. So you could put a parenthesis here, okay? So you know it's not minus. This is what kids will do. They'll write it like that, times negative sign. That looks like a big minus sign. Either put parentheses around it so you know, or better yet, as you get better at doing this, that negative is just going to make that become a minus. So it's really that right there. Okay, so there should be a plus right here, right? Because the product rule says there's a big plus in the middle. But because cosine derives to negative sign, it just turns that plus into a minus because it's all multiplied on the back there. Questions on that one? Radio silence. Crickets.
Wait, so do we just leave it as it is, like after you're done?
Right there? Yeah, that's it. Cool.
I mean,
Yeah.
for like number 1, or would you like put the sign over the 2 root x?
Good question. You could leave it like this, and there's nothing wrong with that. And if we were going to work with this further, maybe that's a good idea to do. But for right now, Everything I'm asking you to derive, I just want to know, can you derive it? I'm not worried about the simplification of it yet. Cool. So both of those are fine. The only thing I want in terms of simplifying, what I expect you to do is no complex fractions. That means no fractions in fractions, and no negative exponents. So if you have negative exponents, just rewrite it so they're in their correct place. That's all. Other than that, I don't care how you simplify it. Because some of the stuff I'm going to give you is going to be nasty derivatives, and that's just me seeing, can you derive this function? The stuff after this unit, after we learn how to derive, we're actually going to use it to do some things. Okay? All right. So we have a product rule, which means we also have a division rule, right? It's called the quotient rule. And it looks a little complicated, but it's slightly similar to the product rules. Check it out. We have a top function and a bottom function, right? The quotient rule says if you have to derive a fraction, a quotient, you leave the denominator. Don't derive him, derive the numerator. And instead of a plus in the middle, you get a minus. And then same thing, there's product rule though, you leave the first, derive the second. Now the order in this matters, okay? In the product rule, it doesn't matter which one you derive first. But in the quotient rule, you have to derive the numerator first and leave the denominator as your first piece right here, okay? And that all goes over the denominator squared. And the reason why this is happening, this squared is happening here, is technically because that g of x is to the negative first power. So it becomes, the power rule's happening in there as well. If I showed you all the pieces coming together, lordy, lordy. Okay, so here's my example of that, and then I want you to try those two down the bottom, and we'll go over those. Why are you clicking on all this stuff? There's no reason for you to be doing this. Why did you name call?
I don't know, I didn't.
What the hell did you get up on? Try to go back in, okay?
What do I have to press?
Go to the Chrome, go to the
The ocean. Cold, and then I pulled it out.
It wasn't called, do you remember?
That's what. I mean,
Bluebird.
The ocean will never flood. It was like flat, like Nemo used that metaphor. It was in, the water comes out,
Daddy, I can't get back in.
back up. All right, what did you learn from the story?
All right. Calm down, okay. You're right. This is it. This is the limit. Grade 1. Maybe she got kicked out. Okay? So, wait a few minutes. We'll try again. Okay? Because if she got kicked out, she's not there anymore, then we can't get into it. Okay?
Well, then what happened though to the other one of the other kids?
I don't know. I guess they're trying to get back in too. But for right now, wait. Okay? Okay.
Can I see some baskets?
No, you can go in the sunroom and play and shut the door.
Mr. Smith,
Yeah.
is it possible to reduce, or is it possible for everything to turn into one big function for the second one?
Yes. And we'll talk about that. Yes, that's there for a reason, right?
Okay.
Okay. But by the quotient rule, here's the first one. Okay, right? Leave the denominator, derive the numerator. It's right here. Minus, leave the numerator, derive the denominator, the bottom. Cool. Over, bottom squared. Okay, and actually, there's like a little mnemonic device for this. Okay. If you think about this as the high function, like the top function, right? High and low, right? The mnemonic device for deriving a quotient, super fun to say, is low. That's the low function. D high, that's the derivative of the top function, so low D high, minus high D low, the derivative of the low function, over low squared. So low D high minus high D low over low squared. It rolls right off the tongue. Okay, if you've got a better mnemonic device, you let me know. Okay, you can change the course of history in calculus. Now, the derivative, sine over cosine is tangent. Like, you all know that's tangent, right? Cool. So the derivative of that is going to be, by our rule, I told you, secant squared. We saw that. Cool. This is just me showing you why it's secant squared based off of this. So h prime of x, if we use the quotient rule, would be leave the denominator, derive the numerator. But derive sine would become cosine, right? Minus, leave the numerator, derive the denominator. But the derivative of cosine is negative sine. So you could put a negative sign here, or you could put sine and change the sign of this thing up here. It becomes a plus over the low squared. That's how you write that. But that turns out to be, as you can see here, cosine squared plus sine squared all over cosine squared. Now, a couple things. Please, 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 do not cross out those cosine squareds. You can't. If there's a big plus up top, you cannot cancel division. Division cancels multiplication, okay? So you can't cross those out. But a big plus there, cosine squared plus sine squared, everybody knows is 1, right? That's that Pythagorean identity you learned back in Trig. So this is really just 1 over cosine squared x. And 1 over cosine is secant, so 1 over cosine squared is secant squared. That's just us showing it. Okay. So I don't know if this is overwhelming at this point or not, on how you're feeling, but I have great news. There's just one more rule left. All right? And that's all of derivatives. After this, like, you have to practice and get these rules down, but you'll be able to derive any function that comes your way. There are no more derivative rules. Okay? Let's review what we got. Individually, we can derive types of functions. Okay? That's the first few rules. We can derive, again, a number times x to a power. We can derive the trig functions. You're going to memorize those. We can derive exponential functions, which you have to memorize, but that'll count for all exponential functions there. We can derive logarithms. Okay? Then we can derive combinations. Oh, arc trig also, I forgot those. We can derive the arc trig functions. Okay? Then we can derive combinations. Plus and minus is our favorite because we can just derive each piece individually. Multiplication, a little bit of pain in the butt because you got to use this product rule, okay, but not terrible. Just derive 1, leave 1, plus leave 1, derive 1. Then we have the quotient rule, which is similar to the product rule, which says leave the bottom, derive the top, right, low d high, minus leave the top, derive the bottom, high d low, all over low squared. And low squared doesn't do anything, it's just there, okay, bye, because, again, I'll show you later on why that's happening. Okay. And the last rule we need is called the chain rule. And this is, I think, a lot of times for students, it's not the most difficult, but it's the one that they miss or that they forget in a question. Dude, do you see what I'm doing right now? Do you see what I'm doing? No, go in this. Get your butt in front of me. Okay. So I get myself in trouble over here with playing with my kids because my like serious dad voice is the same as my goof around wrestling voice. So they think I'm playing sometimes when I'm, trying to really tell them to calm down. Anyway, that was me playing around with him. But what kind of kid walks into calculus class and just starts talking? Have some respect. Anyway, we've got, if there's a function inside of another function, so not multiplication, but it's plugged into it. That's called composition, okay? So I want you to notice the difference. There's a lot of stuff going over here. Uh-oh, that's not good. That's my vet calling. We got a function plugged into another. So I'm going to show you two. So this is sine of x squared with x squared plugged in, which is different than this function I'm making up over here, which is sine of x times x squared. Okay, this is the product rule. That's what we would use there, the product rule. Over here, that thing's inside of sine. You got to pay attention. And that's what I mean. Like, this is not the hardest rule by any means. It's just the one that kids miss the most because of bad notation, because they're sloppy. Like, how many times are you guys writing in your notes and you write like sine and don't put anything inside of there, okay? You should really get used to writing sine parentheses, and there's something in there, even if it's just an x. Get used to that. It's not sine, it's sine of x. Okay? So that's sine of x squared. Here's works. All it really does is adapt all our individual function rules. Okay? So it says this. If there's an inside function plugged into another function, to derive that whole shebang, you derive the outside function while leaving the inside function there. Okay? For instance, when you derive sine of x squared, it's easy to see the inside function is that x squared. Right? X squared is inside of sine. So when you derive it, you derive the outside function, which is sine, and that becomes cosine, and you do not touch the x squared. Boom. But you're not done. That's just deriving the sine part. Then you're going to multiply that by the derivative of what's inside. That's what the chain rule says. So we need to multiply this by 2x, because that's a derivative of x squared. Okay? And normally you put like the trig thing at the end, so I just rewrote it here. That's the same thing. You put the 2x out front. So real quick, let me just go over here and talk about inside versus outside functions, okay? So this is x squared plugged into sine. We just derived that, okay? This is sine plugged into x squared, which is different. Cool. Which you might also see is this. So this is kind of hard to recognize sometimes. But that's sine being squared. Okay? We know the derivative of x squared. If that's y, then y prime is 2x. Right? You bring that power down. So the derivative of sine squared, of anything squared really, is 2 sine x. That's deriving the squared, right? Times the derivative of what was inside the squared, which was sine. So it's really cosine. That's how you derive something squared. All right? And actually, I'm going to go back and change all our rules next class and show you what's up here. But here's a couple to practice, then I'm going to let you go. The derivative of cosine with something plugged into it, chain rule says, again, this is not a product. You derive cosine. That becomes negative sine. Then you multiply that by the derivative of the inside, which would be 12x cubed. Okay? So something I always say to my kids when we're doing the chain rule is you think about a function with like layers. This is a terrible analogy, but like, have you ever seen Shrek? He says ogres are like onions. Okay? Many layers. Functions are like onions too. Okay? Lots of layers in there. All right. And when you're using the chain rule, what you're doing is you're peeling away those layers and deriving each inner thing. Because there could be more than one function plugged inside here. There could be like a triple chain rule going on. Okay. But if you attack this from the outside, cosine is what you derive first. Boom. And then you peel it away and derive what's left inside of that, 3x to the fourth. When you derive number 2 here, h prime of x. That's the square root of tangent, right? The derivative of any square root of anything, as long as it's a square root, not like a cube root, is 1 over 2 root, the same thing. Okay? That's just the power rule. That's a half tangent to the negative a half. But then I need to multiply that by the derivative of tangent, which is secant squared. And yes, you can put the secant squared on top. Eventually, we will get to simplifying these things. But for right now, I'd really prefer, if you're writing it out, you keep them separate. So that way, when I check it, I can see you're doing each piece. Are there any questions? Everybody feeling good? There is some more practice down here. But how about you hold off on that? Some of these are like extra hard for no reason. Okay, let's talk about those on Monday. And for homework, I want you to do what we had on Canvas. All right? Which we go into here. I'm in Calc C. Which I don't want to be. So actually, let me stop recording here too. We don't need to see all this junk.